Hello everyone and welcome to This Week in Net. It's the May the 31st, 2024 edition, and this week it's an episode dedicated to our segment called Let's Get Technical. I'm João Tomé, based in Lisbon, Portugal, and with me I have, returning to the show, our CTO, João Graham-Cumming. Hello John, how are you?
Hi João, how are you doing?
I'm good. We have a bit of surprise in a few minutes, but before that, let's go to a bit of history. So TCP, the protocol TCP, is doing this month, May, 50 years since the paper from Vint, Cerf and Kahn was published. It was in May 1974, and it was published by the IEEE, so the organization in terms of engineering, published that protocol, the transmission control protocol at the time. So 50 years is a long time. Most folks don't know what TCP is all about, but they sure use it in a sense, right?
Well, they do. And so, you're referring, I think, to our RFC 675, which was the RFC that came out of the article you're talking about. And what's interesting about the original description of TCP is it's the first thing that actually refers to the internet. It refers to an internetwork, which is what the internet is, right? It's a network of networks, and uses the short form of internet, if I remember well. And so that's actually, interesting in itself. And the TCP protocol, what's amazing is, I can't believe it's 50 years, is the fact that we have this protocol, which was created when the network essentially didn't exist, and has really stood the test of time with only quite minor tweaks over a 50-year period. And I think perhaps its most important feature is that it has prevented the internet from collapsing under its own weight. Because of the way TCP works, it is able to prevent what's called a congestion collapse, where you just get congestion to the point where the network no longer works. And it has a method of doing congestion avoidance. It's quite a simple mechanism doing congestion avoidance. It's not without problems, but it has stood the test of 50 years' time. So, you and I getting to speak to each other today, thanks to TCP, and we're all using the internet thanks to TCP. So yeah, 50 years of internetworking and TCP.
It's a long time. I was checking actually some of the celebrations recently, one with Vint Cerf and Kahn speaking about the fact. One of the things that surprised me was in the beginning, they weren't thinking of so much success. So they didn't plan for so many networks, so many success in a sense. It's kind of quite interesting how now there's a whole different industries online, so they live online. It's quite interesting to see how it plays out.
I totally agree. I think they were building a sort of theoretic. So if you think back to that time, there was a real question about packet switching and whether using packets was the right way to go. And there were different packet switch networks around, and they proposed a particular packet IP, and then this protocol on top of it to guarantee delivery of messages or data, and it turned out that the internet won in terms of being the network, partly because of its openness, and this protocol is here, and here it is. So.
And this week I'm also sharing some videos I recorded with folks from our team, from experts on the protocols, discussing a bit on this topic, like Mark Nottingham, and also Marwan from our research team. So different opinions about the evolution of TCP to what we have today.
Absolutely, and of course we do have Quick now as well, which in some ways is replacing TCP, because there are some problems with TCP, but nevertheless 50 years is a pretty good run for a piece of technology. It's if you think about technologies that are 50 years old and still being used, there aren't many, and so it's a testament to how powerful TCP is.
I have a question for you specifically on that, more on the science side, papers doing science, and science that then becomes technology, becomes something that everyone uses. In what way do you think TCP as a beginning, this paper as the beginning of something, was made of that type of collaboration? For example, Vint Cerf actually explained this, they build on what was before them. So it was a building block, TCP, from what was before already, and others build on what they did with that paper. So it has a lot of science, technology put together perspective here, right?
Yeah. I mean, the thing is, at the time, there was another network being developed in France called Cyclad, which had some similar ideas for what was happening with, internetworking and how stuff would be transmitted. So there was a rich period of experimentation around internet protocols, how you transmit data successfully in a network, and in the US, of course, the ARPA net had been created for this kind of experimentation. So this was a really rich area. Because the other way of doing this stuff was the very, very connection-oriented way of thinking about networking, which is how the phone companies thought about networking, right? Which is like, originally, like if you made a phone call, you got a physical electrical connection from your phone to the other person's phone, right? Originally, it was like, and that was a circuit, right? We thought of that thing as a circuit. It was literally a circuit. And so the concepts of circuits were very powerful in telcos, and they got added to other protocols over time. So if you look at other protocols around like networking for data, in particular X25, they use this kind of concepts of circuits and reliability and quality of service and stuff like that. The internet protocol stuff took a completely different approach, which is a bit more of a sort of wild and wacky approach, which is rather than saying there's some guaranteed circuit between these two machines or people, they said, well, we'll just throw packets out into this network and the network will somehow deliver them or not, because it's not necessarily reliable. And that turned out to be that flexibility, that packetization, just turned out to work really, really well in the real world and deal with all sorts of problems. Whereas something like X25 was a bit more rigid. What was good about the circuit version is it made it very easy to charge people, right? If you knew who was connecting to who, how long they were connected for, how much data they sent, it made charging and that's why phone companies liked it, right? It fit into a model which was like there's a connection, a circuit, we charge per minute or whatever. So that was what was happening at the time. Both protocols lasted for a while, right? X25 was around for a lot longer, for longer, but ultimately this packetization way of doing things changed the world, and here we are using packets for everything.
Exactly, the global village, as you usually say, in a sense. Let's go to Taylor Swift. Taylor Swift, for those who don't know, did a concert.
TCP to Taylor Swift.
Sorry.
Let's just change direction. Yeah.
Exactly. And in this case, for those who don't know, she performed 2 concerts in Lisbon this past weekend. I think now it's going to Madrid in Spain, so it's the Eras Tour. And you did a specific little thing regarding something really popular in that concert, which is everyone has these little things, wristbands, and these wristbands, kind of amazing, contribute to the spectacle, to the show, because they have lights in it, but the lights connect with something and they are coordinated in a sense. So a full big stadium like the Benfica Stadium here in Lisbon with over 60,000 people has these little lights in every wrist in folks there, coordinating, doing all sorts of choreographies, light choreographies.
Yes, that's right.
And to be honest, when I was leaving the concert on Saturday, I was thinking of this because my kid wanted to see this. And I was thinking, hey, this would be great to be used externally outside the concert. But I get that this was like connected to something there in the stadium to the lights to appear. So I got home, my 8-year-old kid was asking me to put this like working, and it was not working because it was not connected to the cell towers, I believe. So I was thinking how maybe John knows a way of putting this to work. And then today I saw you wrote a blog post related to this, how this works. So can you explain to us?
So I have to, there's some disclaimers here, right? I don't think I could name a single Taylor Swift song. and I didn't go to the concert. So I'm ignorant of what happened in the concert, but Matthew Prince, Cloudflare's CEO, did go to the concert, and he had the same thought as you, which is, I bet John can figure out how this works. And I went out to dinner with him the day after, and he gave me 4 of them, which I'm wearing on my wrist, my left hand here. And so I have 4 of these things, and he wanted to know how they work. Well, actually, luckily, a bunch of reverse engineering has been done of these things, but I have to say this thing is a beautiful piece of technology. It's very, very simple. So essentially how this works is each one of these things, the little black thing you can kind of see in here, that is an infrared receiver, exactly like on your TV when you use the remote control, exactly the same. And what's happening in the stadium is there is a really, really big TV remote. Okay, you can think of it like that. There's a very big infrared projector. You see that little black thing there. There's a big infrared projector in the stadium, which is movable, and it points at the audience and it covers a section of the audience and sends out an infrared signal saying, do this, change to this color, fade to orange, flash, whatever you want the effect to be. And by shining infrared light, like shining that remote on the audience, by moving it around, you can create all sorts of amazing effects. And it really is that simple. It's a very clever, simple piece of technology. And of course, the obvious thing is if it's infrared, since infrared is such a well-developed piece of technology, can you control this? And of course, some people have gone and reverse engineered the signals. And if you've ever used a universal remote, you've used this kind of thing, right? Where it can produce the signal of your TV. And if you've ever used a learning remote, you kind of point one remote to another, right? And they learn the signals. So some people did that with one of these. This is a Flipper Zero. They went to a concert, I believe it was Coldplay. They used the same technology, and they recorded some of the infrared coming out. And then that was the beginning of a reverse engineering effort to figure out what signals do what. The upshot is you can control these things outside the concert. And actually, some people have made a Flipper Zero project, because Flipper Zero has a little infrared emitter and receiver on the end. So Flipper Zero can pretend to be a remote, and it can pretend to be a remote for these. So you can send a signal. I hope you can see that. So that's orange. And you can go in here and you can choose a different color, so a different sort of orange color, and then that was meant to be pink. And so you can go and find, you can go and play around with these things and do different effects. Here's some red. There's also the fade effects, which they use in the concert, where they'll tell, if you imagine they sweep the remote around, telling them to fade, and then you get this fading, moving effect sweeping across the audience. And the interesting thing about this is that in some ways it's very low tech. It's like a remote of a TV. And some of the effects they can do are make shapes in the audience. And again, this is actually very simple. What they do is in the front of the emitter thing, which is a big circular thing like this, they put a cutout shape. So you put a heart in front of it, and then the infrared light hits the audience in a heart shape, and only the people inside the heart will light up in red, presumably, or whatever color. So this is a very, very simple technology. If you want to play around with it, you can go on GitHub. You'll find there are projects for this. The only thing is it eats batteries very fast. So the batteries, which are completely replaceable, are last a few hours. Yeah, they're a standard CR 2032 standard sort of thing that you would have in any gadget. They only last a few hours because they're only meant to last the length of the concert. Now, the other thing about this is when you look at this, you might think, oh my God, all that e-waste because of all this kind of stuff. But actually, this thing was made to be reused. And at concerts, what they do is they encourage people to give them back in again. And rather than being a very, very sealed up piece of technology, as you showed in yours, they were actually designed to be opened, right? So a lot of consumer electronics, I mean, even the Flipper Zero actually is screwed together and is quite well put together. But a lot of this sort of disposable consumer electronics is difficult to open. This you can actually open with your fingers, like I just did. And you'll find inside that, a couple of batteries and a little printed circuit board. Here's a little printed circuit board from a company called Pixmob in Montreal. Very simple piece of technology. And so, yes, I wrote a blog post about it because Matthew nerd sniped me into looking at how these things operate. And I was actually really delighted by this technology. It's really quite simple, and it's a very clever use of a combination of simple technology, infrared, been around for years and years and years, perhaps as long as TCP has been around, and the sort of theatrical stuff of just a projector projecting, in this case, instead of visible light onto the audience, infrared, which causes these things to do stuff for you. Let's see if I can, let's have some magenta while we're here, so stuff like this. So
magenta was a popular color in the concert.
So I did write a blog post about this just to talk about it, just because Matthew had nerd sniped me into doing this stuff. So there you go. That's the that's the Taylor Swift. Here
is the blog post.
Yeah, let me see if I can give you. It's like a flashing. You see, you can imagine all these effects being used as part of an audience response to something that's happening with the music. These different sorts of fades, for example.
Exactly. To be honest, I was in the concert really curious on how that was working, because you could see the stands completely with the lights coordinated, really well coordinated. So I was thinking, hey, how does this work? And here it is.
They're actually using a very common lighting technology called DMX, which is often used in theater and in big concerts. And because of that, I think it integrates very well with the music, with the lighting rig, so it becomes part of the overall lighting for the show, except that each person, has got some thing on their wrist and wants to participate.
Exactly. Folks participate even in the light show, which is really interesting. And I really love the design with love in Montreal inside. So it has that little detail inside of the device for those who open it.
It's a very simple device. If you look at what's on there, there's a couple of LEDs, there's a receiver for the infrared, and there's that chip, that 8-pin chip there is a microcontroller actually specifically designed for remote controls. So it's just a very simple thing. And there's a little bit of memory. And that's it. So all the smart stuff is in the transmitter and the way in which someone designs the light show. So yes, you can take yours home. You can get out your Flipper Zero, which of course you all have, I'm sure. And you can, walk around the house looking like a total dork, as I am, who has never been to a Taylor Swift show.
I have one, but I'm not an expert. I knew one name of a song because my kid likes it, which is "Shake It Off." The others I learned a bit there in the concert.
There you go. Well, you're ahead of me.
Apparently so. Let's move on to our blog, the Cloudflare blog. You wrote a blog post recently regarding using Fortran on Cloudflare workers. For those who don't know, what is Fortran specifically?
Well, Fortran has been around about the same length of time as TCP. It's a very old language. Originally, it stood for formula translation. It was particularly used by scientists who want to take some formula, some scientific thing they're working on, and translate it into code. And it is nevertheless still here today. Goodness knows what that's going to look like. I think that's at 8. And Fortran continues being updated. It used to be Fortran in all uppercase, very, very like original computing kind of stuff, all in uppercase. Over time, it became Fortran in mixed case. What we wanted to do was bring Fortran onto Cloudflare workers and show how you could do it. And there is a LLVM Fortran to WebAssembly compilation. And because Cloudflare workers supports WebAssembly, we're able to take a Fortran program and run it on our network. And this example you're playing with is a very small, simple Fortran program that does letter classification. So it allows you drawing a letter here, a number, and it is then trying to recognize what that number is that you have drawn. And that's a little program written in Fortran, running in WebAssembly on our network. Now, recently, Fortran has been in the news a little bit, if you're into that kind of news, because Voyager, the Voyager spacecraft, which are outside of our solar system, have had, particularly Voyager 2, I believe, has had some trouble communicating with Earth because it is, like all of us, getting a little bit older, and parts of us don't work so well. And so its communications with Earth haven't been so good. Some of the stuff on the ground that manages Voyager is written in Fortran because of when it was created. And so, we see Fortran still existing. It's widely used in science projects. And we just decided we would have a go with Fortran on Cloudflare workers, and sure enough, because it's WebAssembly, we can support it. And you may remember that Sven and I, who worked on this blog post previously, did COBOL on Cloudflare workers. So we're trying to bring back all those old languages, all the languages we can, onto Cloudflare workers, so you can choose whichever language you feel like using.
In a sense, I like this perspective of even old programming languages, old protocols have a place, which is interesting. And some are revamped, as we saw in terms of technology. Some have a new life in some situations, right?
Well, I mean, I think that there's lots of existing code out there. And one of the ways to keep code alive is to keep the languages alive that are run it, and keep them updated and keep them running on new systems. So, one of the difficulties in preservation of code is that the machines disappear. So you need emulation, you need to keep them going. Actually, earlier today, I was doing something just with DOSBox, running a DOS program, running the original version of PKZip. It's great that we can have those emulation layers so we keep this stuff alive. Another way is to change the back end so the systems that are targeted change. And in this case, LLVM gives us Fortran targeting WebAssembly.
Sounds good. Let's go run through the blog for you to select a blog post you want to highlight still. Any that pops out?
I mean, there's been a lot of cable cuts recently, particularly around Africa, right? So, you've had multiple cable cuts affecting multiple countries, particularly in East Africa, but also in West Africa. And there's been a lot of cable cut activity, and then obviously cables have been being repaired. And you follow this very closely with Cloudflare Radar, and so you see the impacts on countries. But one of the issues is Africa, and as the many other places, have a large number of cables. They have multiple competing cables, and you can see on this diagram. The problem is that cables tend to land in common landing points, which means they tend to come together a little bit. And that can create an opportunity for someone to break multiple cables simultaneously. So the classic, example is fishing boat drags its anchor and knocks out multiple cables simultaneously. So these are part of the vital infrastructure of the internet globally. And unfortunately, from time to time, they do get cuts. It's just that Africa over the last few months has taken it particularly badly with multiple cuts, different locations to multiple cables.
True. I think in February it was in the Red Sea specifically. In March it was the bigger one, 3 cables failure in West Africa with 13 countries impacted. And this blog post is mentioning the May failures, problems, in this case in 7 countries in East Africa. So in a sense, the continent has been with problems in terms of cables and not as resilient as potentially it could be in terms of making the failures not impacting internet traffic in those countries.
Yep.
In this situation, Mozambique also.
Exactly. It's been a busy time for cable cuts. I mean, as you say, in the Red Sea, particularly because of the sensitivity where you have Saudi Arabia and Yemen, there's a war going on, and you have rebels who are attacking shipping, but also potentially attacking infrastructure as well. That's a particularly sensitive spot, and it's a fairly small area where the cables cut through. But we've also seen now too, like Svalbard, right? Svalbard, right over in the north, also had a cable cut. I mean, these things, Shetland Islands, I seem to remember in the UK not very long ago.
True, yeah.
These cables are sensitive to accidental and deliberate tampering.
Absolutely. Any other blog posts you want to mention from the list, the recent list here?
Well, I mean, we continue rolling out the new LLM models. Llama 3 from Meta is available on Cloudflare Workers. So if you're using or building or experimenting with AI, you can do so on the Cloudflare platform. And we roll out those models. Obviously, we have a relationship with Hugging Face, where you can go to Hugging Face and select models and get them running very, very quickly on Cloudflare's network. I think that's significant if you're doing work with the AI. And if we scroll down, I mean, there's a lot of new stuff that's been going on at the company. I think that one significant thing here is the Let's Encrypt certificate change. So Let's Encrypt, which issues certificates, right? Very widely used, free projects, super important part of how the internet operates today. Their cross-sign chain, so how they actually create their chain of CA certificates, is expiring in September. And that causes an issue for older versions, particularly of Android, which won't be able to work with the newer certificates that they issue. And because Cloudflare uses Let's Encrypt as one of our providers for certificates, that could have caused us to be issuing certificates that were not valid for a certain subset of the population who are using older phones, older Android devices. And we don't like doing that. We like to make sure that we have maximum availability for people around the world, no matter what kind of devices they're using. And so we have a plan here for how we're using other CAs until we feel like the percentage of users who are really on those old versions is really, really de minimis. And when it is, then we can switch things over. But we'll be making sure that no one gets affected by this change in the chain which is coming up fairly soon.
Makes sense. There's a lot in terms of what we announced recently, but we already did a good run through some of the blog posts here. And those building on workers on our platform definitely have more possibilities there in terms of models, in terms of possibility, really.
Yes.
Before we go, a short little news regarding ICQ is shutting down after almost 28 years. For me, ICQ was important in the 90s.
Yeah.
It was one of the first messaging apps that one can use in the computer. Do you have any ICQ stories?
You're going to be blown away by this. I never used ICQ.
What was your go-to at the time, the 90s?
So
I remember also IRC. I used that a lot at some point.
Yes, I used IRC. I used AIM. I used Yahoo Messenger, actually, probably the most. That was probably one of my biggest chat applications. And then after that, I think the world opened up into so many different things. Now I get messages on so many different platforms. I'm kind of lost. So, but yeah, it's funny. I never used it. I was seeing it going away because I run another website. It's called 2StopBits, which is about retro computing stuff, and there were a bunch of people there talking about that. And I was like, you know what? I don't remember that I had an ICQ number.
It was really, it's kind of amazing how well designed those tools were. Winamp also for music, really popular. And there was not many possibilities at the time. So I think those resonate to those who use it at the time as the main go-to for messaging. It was important at the time, even if it was just a few years. Some trivia there. And we end up there. Thank you, John. This was great.
You gotta do some sort of light show thing, right? I mean, that's part of the whole ending.
That's true. That's a good way to end.
We're not a fade. Here, I'll give you a very slow purple fade. Bye, João.
Bye-bye. Sounds good.
Good talking to you.
And that's a lightning wrap.
Cheers.
To ask a more broad question, why is TCP important?
TCP is fundamental to the internet.
Relatively speaking, it's one of the few technologies that has been able to persist.
TCP is the the part that most internet software uses on a constant basis.
I suppose to understand why TCP matters, you should have to go back to the beginning and understand the environment in which it was designed.
When we talk about internet protocols, the core, what they call the narrow waist, or what everything kind of funnels through, is TCP IP, this pair of protocols.
There's been lots of things that have come and gone or been overtaken by newer versions and updates, but TCP is a great example of something that's what I like to think of quite elastic.
How do I know that a packet has reached its destination? Or what if I send too fast for the receiver to understand the message that I'm transmitting? So TCP accomplishes these and later a little bit more